A modern pool enclosure relies on thin mesh and lightweight aluminum extrusions to maintain a perimeter against insects. In high wind conditions, this assembly converts into a 2,000-pound aerodynamic sail, absorbing massive energy from the atmosphere. This 3D schematic outlines the legal baseline for structural survival in the state, the Florida Building Code, 8th edition. Enclosures must now adhere to the ASCE 722 wind load standards to maintain structural integrity under extreme atmospheric pressure. Survival during a major hurricane is a matter of site-specific mathematical proof. We can break down the engineering of these structures by following a first principles teardown, beginning with the subterranean foundation and moving up to the coastal grade roof. This stress test diagram maps out the forces required to prevent a massive aluminum addition from turning into a high-velocity projectile during a storm. Engineering begins underground, mapping the exact property lines through a top-down boundary survey. Municipal building departments require mathematically precise surveys from licensed professional surveyors and mappers. They universally reject hand-drawn sketches or any survey older than 12 months without a notarized affidavit. This graphic illustrates the primary hurdle for any new construction, the Impervious Surface Ratio, or ISR. Cities limit the percentage of a property covered by surfaces that block water to prevent neighborhood flooding during heavy downpours. While screen mesh allows rainwater to pass through, the concrete pool deck and the structural footers required beneath the enclosure do not. If the mass of these required footers pushes a property over its legal ISR limit, the city denies the permit immediately. Beyond water drainage, contractors must navigate a secondary subterranean maze of hidden underground utilities. This diagram illustrates hazards governed by Department of Health Chapter 64E-6 for homes using septic systems in counties like Orange and Lee. The law mandates a strict 5-foot buffer zone where no permanent structure or heavy machinery can cross. Aerodynamic engineering is only possible if the structure first clears these local topological and hydrologic laws. During a storm, high-velocity winds create a localized low-pressure zone above the structure, generating thousands of pounds of vertical uplift. This is known as the parachute effect. A screen cage catches horizontal wind currents and converts that energy into vertical force. The cage remains attached to the property because of the massive subterranean ballast buried directly into the earth. Modern codes mandate continuous 12-inch by 12-inch poured concrete footings, reinforced with steel rebar cages. The weight of this continuous concrete trench provides the ballast required to anchor the cage during a Category 4 event. Cheap, generic footings lack the mass to withstand these loads. During a hurricane, these smaller footers can simply rip out of the ground. A 2,000-pound aluminum superstructure relies entirely on the mathematical sufficiency of its subterranean anchor. Moving from the foundation to the frame, the most common point of failure is at the joints, rather than the aluminum beams themselves. Galvanic corrosion is the primary, invisible threat to these structural connections, slowly eating away at the metal from the inside. This slide shows the result of standard steel screws touching an aluminum frame in salty coastal air. The contact triggers a rapid chemical reaction that deteriorates the metal. This corrosion occurs inside the joints, out of sight. The weakness typically goes unnoticed until the storm winds arrive and the fastener fails. Modern engineering mandates specific hardware upgrades to prevent this chemical breakdown. To maintain tensile strength, contractors must use 316 or 410 stainless steel hardware combined with ceramic-coated finishes. Advanced fastening technology, such as Nylotech or Tapcon anchors, is required to secure the base of the frame into the concrete. A single corroded screw can lead to an entire structural collapse. Survival depends on the specific chemistry of every fastener used in the frame. Across Florida, the mathematics of survival change significantly based on the property's exact location. The primary metric for this engineering is the Ultimate Design Wind Speed, or VALT. This chart compares building requirements, starting with the strict standards of the Naples coastal zone. Coastal Risk Category 2 structures must withstand VALT loads of 160 to 170 miles per hour. These builds require maximum extrusion thickness and heavy internal gusset bracing. In the Orlando Inland Zone, the environmental focus shifts. The required wind load drops to 130 or 140 miles per hour, which allows for standard high-wind structural requirements. Within a single zip code, microenvironments called exposure categories alter the engineering further. Exposure D properties sit in a maximum impact zone with unbuffered wind. These locations require 7 to 8-inch upright posts that are unnecessary in buffered suburban areas. Contractors often use generic master plans that ignore the aerodynamic shape of the specific roofline. Because every home has a different pitch and height, wind creates unique uplift forces that must be calculated individually. A pool cage designed and priced for Orlando will structurally and legally fail in Naples. Quoting both regions identically is a guarantee of structural failure. All of these engineering factors result in a structure capable of standing strong in the most severe weather. Compliance with the Florida Building Code 8th edition is a 3-part system that ensures long-term survival. First is clearing topography through certified boundary surveys and strict ISR adherence. Second is implementing coastal-grade metallurgy, using 316 stainless hardware anchored into steel-reinforced footings. Finally, the structure is tailored to site-specific aerodynamics, matching exact regional wind loads and the roof pitch. Avoid contractors who quote identical materials for high-velocity coastal builds and inland projects. Engineering plans provide the mathematical foundation necessary to protect your home and your family. Screen Factory Florida applies these engineering standards to every project to ensure your backyard enclosure survives the